Alright, so in the second video here, we're going to do numbers 4, 5, 6, and 7 in the multiple choice AP style. So right off the bat, we have a definite integral. I'm going to use U substitution. At least that's my initial plan. I'm going to go with U equals x squared because I want to try and get, that du is going to let me know right now if I have a plan of attack. And you're going to notice that this x minus 4 presents an issue. So I'm actually going to try a different strategy here. I'm going to break this into two integrals. Okay, I'm going to use the sum property for integration, and I'm going to do x over x squared. So I'm actually going to divide this, and it's going to be 1 over x. And then I'm going to divide the negative 4 in the x squared. So I'll just go minus the integral from 1 to 2, and it would be 4x to the negative 2. So before I begin, what I essentially just did is I rewrote the integral split, divided the x squared, the denominator, into x, which was 1 over x, and into 4, which is 4x to the negative 2. So how this is going to work is the integral of 1 over x is the natural log of x. So I'm going to want to plug in 1 and 2 there, give myself an answer. And then over here, the integral of 4x to negative 2 would be negative 4x to the negative 1. And again, I want to plug in 1 and 2. So what's going to happen is I'm going to get, an area for that integral, an area for this integral, and I'm going to subtract these two. Okay. So right off the bat, I have the natural log of 2 minus the natural log of 1. Natural log of 1 is 0, so this just gives me the natural log of 2. And the second one, remember that negative 4 to the x, negative 4 times x to the negative 1 is just this. So if I plug in 2, I'd end up with negative 2. And if I plug in 1, I end up with negative 4. So negative 2 minus negative 4 is positive 2. I want to minus these. So my answer would be B. Number 5, it says that a function is e to the x, and I want to find the natural log of the derivative value at 2. It's kind of a goofy notation there, but let's start off by finding f prime of x. F prime of x would be the derivative of e to x, which is e to the x. If I plug in f prime of 2, that would be e to the second. And then lastly, if I take the natural log of e to the 2, natural log and e actually are inverses of each other. So I end up with just the number 2, which is A. Number 6 wants me to take this product rule and derive and get the slope at x equals 2. So product rule says first times the derivative of the second plus second times the derivative of the first. Let's just double check that. First derivative of the second plus second derivative of the first. Looks good so far. I'm going to go ahead and just plug in this 2 right away. So this is going to be e to the 4th. And that's going to be times 3 times 2 squared is 4, so that's 12. Plus 2 cubed is 8. Plus 1 is 9. And that's going to be times 2e to the 4th. So right now I have 12e to the 4th plus 18e to the 4th. Those combine to be like terms and make 30e to the 4th. In number 7, It's asking me to find the derivative of the natural log of cosine pi over x. So remember that if I want to derive natural log, I actually have to do u prime over u. And in this situation, u is the cosine of pi over x. So let's start with u prime. U prime is actually negative sine pi over x, and then we have to actually chain rule the interior. The interior, just so we know, is pi x to the negative 1, so the derivative of that would be negative pi x to the negative 2. So I'm going to chain rule the inside as negative pi x to the negative 2. And so before I simplify, my u prime over u ends up being, I have two negatives here, these will cancel. I have pi over x squared, and then times sine of pi over x. That is the numerator. The denominator is the cosine pi over x. Using my fraction properties, I can tell you that this x squared is going to crawl down here. This is part of the trig function. This is part of the trig function. So I end up with pi on top with sine pi over x. And then on the bottom I have my x squared and cosine pi over x. So these two expressions make tan. And so I end up with pi over x squared times the tan of pi over x. And I can see that right here for letter E.